Our entire history began by looking up. Ancient astronomy was the silent architect of our world, the original blueprint for everything from our cities to our kings. By the end of this journey, you will see the night sky not as a backdrop, but as the active force that built civilization itself. How did a star cluster tell an emperor when to go to war? Why would a pharaoh align his tomb with a specific constellation? We will trace how humanity's first great societies from Egypt to the Americas used the cosmos as their clock, compass, and scripture. This story reveals that our leap from small tribes to vast empires was written in starlight. What part of our modern world still feels guided by those ancient, celestial rhythms? The ocean is a vast and trackless desert, yet ancient sailors crossed it with confidence. They carried no maps, no magnetic compasses, no blinking screens. Their entire navigation system was etched into the dome of the night sky. This was humanity's first GPS, a global positioning system written in constellations. For travelers in the northern hemisphere, the North Star, Polaris, became the ultimate fixed point. Because it sits almost directly above Earth's North Pole, it appears motionless while all other stars wheel around it. Find Polaris and you instantly know which way is north. This single, constant light transformed the chaos of the open sea or the featureless expanse of a desert into a navigable grid. But this celestial compass was not a one-size-fits-all solution. Different cultures looking at different skies found their own guiding lights. The brilliance of ancient astronomy lies in its adaptability. While one civilization fixed its gaze on the north, others looked elsewhere entirely. Consider the Polynesian voyagers, the greatest open ocean explorers in human history. They settled islands scattered across an area of the Pacific Ocean larger than all the continents combined. To do this, they developed a system of wayfinding so sophisticated it feels almost like magic. They memorized not just individual stars but entire star paths. A navigator would know that to reach a specific island, he must sail toward the point on the horizon where a particular star rises. As that star moves, another takes its place, creating a celestial highway across the ocean. They called these star compass routes mental charts of the sky that connected origin to destination. They also read the ocean itself, the swell patterns, the flight paths of birds, the color of the clouds, but the stars were their primary roadmap. This knowledge was not written down. It was sung, chanted, and passed from master to apprentice through sacred oral tradition. To know the stars was to hold the power of life, death, and connection. This mastery was far more than a technical skill. It was a form of sacred geography. The sky was not separate from the world. It was the world's highest map. By learning to read it, humans could finally move with purpose over staggering distances. This changed everything. Isolated communities were no longer isolated. Trade routes could be established and reliably followed. Ideas, technologies, and stories could travel as far as a ship could sail, carried on currents of wind and guided by starlight. The ability to navigate transformed separate points on a map into a network, and from networks, empires grow. Reliable travel meant resources could be gathered from afar, armies could be coordinated, and messages could link a central ruler to distant provinces. The celestial compass did not just prevent people from getting lost at sea. It guided humanity out of isolation and into the age of interconnection. It was the essential first tool for building something larger than a single village. But what happens when this cosmic guidance system is brought ashore and used not to navigate oceans, but to anchor an entire society to the heavens? The answer lies not in the wandering stars, but in the sun's unchanging, predictable path. The sun's journey is the most powerful clock we will ever know. For a civilization built on farming, a single mistake in timing could mean the difference between a feast and a famine. The sky's predictable rhythms offered the solution, transforming anxiety into order. In ancient Egypt, the entire society's heartbeat was synchronized to one celestial event, the heliacal rising of the star Sirius. After a period of invisibility, Sirius would reappear just before dawn in the eastern sky. This was not just a beautiful sight. It was a cosmic alarm clock that told the people the Nile's life-giving floodwaters were just days away. This moment was so critical it marked their new year. The priests who tracked this star were not just mystics, they were the state's first administrators, using the heavens to manage an empire. By creating a calendar of 365 days based on this solar and stellar cycle, they turned time itself into a tool. They could now predict, plan, and command. They knew when to plant, when to harvest, and crucially, when to collect taxes based on the expected yield. This celestial calendar created a framework of stability that allowed everything else to flourish. Surplus food could be stored because the timing was reliable. A large, non-farming population like priests, soldiers, and builders could be supported because the food supply was predictable. This is the profound shift. Astronomy moved from simple observation to the backbone of state power. The same pattern unfolded across the world. In the Indus Valley, tracking the monsoon rains likely involved observing specific constellations. In the Americas, the entire Maya civilization constructed an intricate calendar system so accurate it could plot celestial cycles thousands of years into the future. Their calendars dictated not just agricultural cycles, but the timing of markets, ceremonies, and royal successions. The sky became a divine schedule, and to read it was to hold the authority to organize thousands of lives. This was the first great administrative revolution, and it was written in the stars. By imposing a cosmic order on the chaos of seasonal change, these early astronomers did more than tell time. They created the very possibility of complex, coordinated society. But how do you make that celestial order permanent, something you can see and touch every single day? The answer lies not in charts or scrolls, but in stone. The blueprint of the sky needed to be carved into the earth itself. Across the Salisbury Plain in England, a silent circle of towering stones has guarded its celestial secret for thousands of years. Stonehenge is more than a monument. It is a Neolithic computer built from stone. Constructed by a pre-literate society over many generations, its very existence proves that the drive to understand the cosmos could mobilize human effort on a staggering scale long before kings or empires. The central axis of the site is precisely aligned. At dawn on the summer solstice, the longest day of the year, the sun rises directly over the heel stone, casting its first light into the heart of the circle. At the winter solstice sunset, the same alignment works in reverse. This was not an accident. It was a deliberate, massive engineering project to pin the sun's most extreme turning points to the landscape. It transformed the abstract concept of a solar year into a physical, communal experience. You could gather at the stones and witness the universe keeping its appointment. But the purpose may have gone far beyond marking the seasons. Archaeoastronomers, scientists who study the astronomy of ancient cultures, proposed that the 56 mysterious Aubrey holes encircling the site might have formed a primitive prediction machine. By moving markers between these holes, which correspond to a long cycle of the moon, the builders could have tracked and anticipated lunar eclipses. Imagine the power this knowledge held. To know, while others trembled in fear, that the moon would slowly be shadowed and then return, was to hold a conversation with the gods. This required not just observation, but advanced geometry, a shared belief system, and a social organization capable of planning decades into the future. The smaller bluestones, hauled from mountains over 150 miles away, speak to a pilgrimage, a sacred gathering. Stonehenge stands as ultimate proof that celestial knowledge was the original social glue. It brought scattered communities together for a common, skyward purpose. creating an enduring symbol of unity written in earth and stone. This impulse to build heaven on earth was not unique to one windswept plain. It became the founding principle for the world's first great cities, where architecture was quite literally aimed at the stars. A tomb could be a stairway to the stars. For the pharaohs of ancient Egypt, the pyramid was not merely a final resting place, it was a launch vehicle for an eternal journey. The world's oldest religious writings, known as the pyramid texts, are inscribed deep within these stone structures, and their language is not of the earth but of the cosmos. Spells and incantations speak of the king ascending to join the sun god Ra in his solar boat, or transforming into an imperishable star in the northern sky. This was the ultimate promise of Egyptian faith, that the ruler's soul would travel to the heavens and live forever among the divine lights. This profound celestial belief was not left to poetry alone, it was engineered into the very stone. The Great Pyramid of Giza is a masterpiece of astronomical alignment. Its four sides are oriented to the cardinal directions north, south, east, and west with an accuracy of a fraction of a single degree. This precision, achieved thousands of years ago, anchors the structure to the fundamental axis of the world. But the alignment goes even deeper. Narrow shafts, once sealed within the pyramid's core, point directly from the king's burial chamber toward specific regions of the night sky. One southern shaft targets the belt of the constellation Orion, which the Egyptians associated with Osiris, the god of resurrection and the afterlife. Another points toward the North Star of that era. This was no coincidence. The pyramid was a precision instrument, a cosmic antenna designed to channel the pharaoh's soul directly to its celestial destination. Think of it as a machine built for immortality, with its alignment as the targeting system. This staggering ambition reveals the true power of ancient cosmology. To build such a machine required more than faith, it demanded absolute authority. The pharaoh's claim to a stellar afterlife justified his god-like status on earth. It was the ultimate reason for a society to devote decades of labor and vast resources to a single project. The state itself became an engine for celestial construction. Farmers, artisans, and engineers were mobilized not by force alone, but by a shared belief in a cosmic order that their king would join. Astronomy here was the script for a theocratic state, providing the divine rationale for centralized power, monumental architecture, and social hierarchy. The pyramid stands as the ultimate proof, a mountain of stone built to touch the heavens, forever linking the destiny of a king with the timeless dance of the stars. Yet this drive to mirror the cosmos in architecture was not confined to the deserts of Egypt. It became a universal language of power, spoken in stone from the jungles of Central America to the plains of China. The court was a model of the cosmos, and the ball was a star in motion. For the Maya and the Aztecs, the famous Mesoamerican ball game was a sacred drama played out with life and death stakes. Teams would battle to keep a heavy rubber ball in play using only their hips, elbows, and knees, striving to pass it through a high stone ring. But this was not merely a difficult sport. The playing court itself represented the world. The ball symbolized the sun or the planet Venus, and the game reenacted the eternal struggle between the forces of light and darkness, of life and the underworld. The outcome was believed to influence the very cycles of nature, ensuring the sun would rise again and the rains would return. In some traditions, the captain of the losing team, or even the entire team, would face a ceremonial end, a sacrifice seen not as a loss but as the ultimate honor, a direct participation in the cosmic order that sustained all life. This profound connection shows how astronomy was woven into the very fabric of existence, from the grandest myth to the most visceral public spectacle. Their celestial calculations went far beyond myth, however, and into the practical realms of power and survival. No star was watched more closely than Venus, the brilliant morning and evening star. The Maya astronomers became master trackers of its 584-day cycle, compiling detailed tables that could predict its appearances for centuries. But this knowledge had a sharp, earthly purpose. Venus was associated with the god of war. Its first appearance as the morning star after a period of invisibility was considered an inauspicious, dangerous time, a moment when the god's influence was strongest. Maya rulers would deliberately schedule military campaigns to coincide with these celestial events, launching raids under the perceived auspices of a war god's power. The sky was not just a backdrop for their battles, it was the strategic commander, dictating the timing of conflict in a society where warfare was deeply tied to ritual and the capture of prisoners for ceremonial purposes. To maintain this precise, celestial scheduling required an obsessive focus on timekeeping. The Maya developed not one, but several interlocking calendar systems of breathtaking complexity. A key to keeping these calendars in sync with the actual solar year was the delicate star cluster known as the Pleiades. In the clear nights over the Yucatan, the Maya observed that every 60 years, the Pleiades would reach its highest point in the sky at midnight on the same date. This long cycle served as a celestial check, a way to correct any drift in their meticulous count of days and ensure their ritual and agricultural calendar remained perfectly aligned with the heavens. Their architecture proves this obsession. At Chichen Itza, the unique round observatory known as El Caracol, or the Snail, is pierced with narrow windows that align with the extreme setting points of Venus and other key stars. It is a stone machine built for watching the gods move. This was a civilization that lived and breathed the cosmos. From the ball court to the battlefield, from the planting of maize to the crowning of a king, every significant action was measured against the celestial clock. The sky was the ultimate authority, a divine script that dictated the rhythm of an entire society. Their genius was in building a world where that script could be read, predicted, and obeyed, creating a seamless unity between the movements of the stars and the fate of their empire on the ground. Yet, if the cosmos provided the ultimate authority, how did that authority manifest in the hands of a single ruler? The answer lies in a concept so powerful it would shape empires for millennia: the idea that a king's very right to rule was written in the stars themselves. The king's fate was written in the movements of a wandering star. In the flat, river-woven lands of Mesopotamia, the Babylonian priest astronomers gazed upward with a singular, urgent purpose. They believed the sky was a living, divine text, and every unusual event was a direct message from the gods. A lunar eclipse was not a beautiful shadow play, it was a potential omen of a king's illness. The sudden appearance of a comet was a warning of invasion or drought. Their entire society, from the harvest to the stability of the throne, depended on correctly interpreting these celestial signs. This was not idle stargazing, it was a matter of national security. The priest's role was to serve as translator for the divine, advising the ruler on how to appease the gods or prepare for coming challenges based on what they saw in the night. This immense pressure to predict the unpredictable led to one of history's most important intellectual breakthroughs. They began to write everything down. For centuries, they meticulously recorded observations on durable clay tablets, noting the positions of planets, the timing of eclipses, and the patterns of the moon. They were creating a database, a celestial archive born from fear and devotion. And within that mountain of data, something extraordinary began to emerge: patterns. They noticed that the planet Venus, for instance, repeated its cycle of appearances every 584 days. They saw that lunar eclipses tended to recur in a predictable series. What began as a search for divine whim slowly revealed a universe of astonishing regularity. From this religious practice, the first seeds of scientific astronomy took root. They developed advanced mathematical models to predict planetary motions and the complex timing of eclipses. Their most enduring legacy may be the creation of the Zodiac, dividing the path of the sun into 12 equal sections, each named for a constellation. This was not for horoscopes as we think of them today, but as a precise coordinate system for mapping the sky, a necessary tool for their calculations. Here lies a profound paradox. The drive to serve the state, to protect the king by predicting the will of capricious gods, forced them to look deeper and more systematically than anyone before. The practical demands of statecraft, the need for order and foresight, fostered relentless observation and the slow accumulation of verifiable knowledge. In trying to read the mind of the gods, they inadvertently discovered the laws of the cosmos. Their work became a cornerstone of intellectual civilization, proving that the quest for celestial meaning, whether spiritual or political, could illuminate the very mechanics of the universe. But if the stars could guide a king's decisions and a society's survival, could they also offer a map for something even more personal, a guide for the human soul navigating an uncertain world? The sky was a direct report on the emperor's performance. In ancient China, the cosmos was not a distant mystery but the ultimate performance review for the ruler, a concept known as the mandate of heaven. This was the sacred contract, the belief that the emperor ruled only with the approval of the celestial powers. A just and prosperous reign was met with heavenly favor, signaled by a stable, predictable sky. But a corrupt or failing dynasty would receive warnings written in the language of celestial disturbances. A sudden comet, an unexpected eclipse, or a guest star, what we now call a supernova, appearing where no star had been before. These were not scientific curiosities. They were urgent political bulletins interpreted as signs of divine displeasure. This belief made astronomy the most guarded of state secrets. The imperial astronomer was not a solitary scholar gazing through a telescope. He was a high-ranking minister operating within the Forbidden City itself. His observatory was a state institution, and his reports went directly to the throne. His critical duty was to watch, record, and interpret every anomaly, providing the emperor with the celestial intelligence needed to govern. If a bad omen appeared, the emperor might perform public rites of penitence, reform his policies, or even issue a formal apology to the heavens in an attempt to restore balance. This system created an astonishing legacy of data. Because these observations were matters of state security, they were recorded with meticulous care on imperial archives. Chinese court astronomers documented the appearance of Halley's Comet as far back as 240 BC, noted sunspots centuries before telescopes, and created the most detailed historical records of supernova in the world. One record from the year 1054 describes a guest star so bright it was visible in daylight for 23 days, an event modern astronomers have identified as the Crab Nebula supernova. This bureaucratic need for celestial accounting has given scientists today an irreplaceable timeline of cosmic events, but the political function was always paramount. The monopoly on interpreting the sky was a powerful tool for centralizing control. Only the emperor and his court could officially read the will of heaven. This meant that a peasant rebellion could point to a comet and claim the mandate of heaven was withdrawn, legitimizing their challenge. Conversely, a new dynasty founding its reign under a stable sky could claim clear celestial endorsement. Astronomy was woven directly into the historical narrative, used to explain the rise and fall of dynasties in a cosmic framework. The stars became the ultimate political tool, transforming celestial mechanics into a language of legitimacy, order, and sometimes revolution. This deep integration shows a civilization that saw no separation between the laws of heaven and the laws of the state. But if the sky could judge emperors and predict the fate of dynasties, could its patterns also offer a more personal guide, a map for the individual soul seeking its place in a vast and ordered universe? Their cities were built like celestial clocks, In the vast floodplains of the Indus Valley, the great metropolises of Mohenjo-Daro and Harappa rose with an almost unnatural order. Their streets were laid out in precise, perfect grids, a level of urban planning that would not be seen again for thousands of years. Unlike the pyramids or Stonehenge, they left behind no towering observatories, no obvious monuments to the sun or stars. Their astronomical genius may have been far more subtle, woven into the very fabric of their daily life. The cardinal directions north, south, east, and west seem to have guided the orientation of entire city blocks and major buildings. This was not random. To align a city so perfectly requires a deep, shared understanding of the heavens, a common reference point that every builder and planner could use. The sun's path provided that immutable reference. By anchoring their world to the four cardinal points, they were literally building their society upon a cosmic foundation. This created a sense of harmony and order that you could walk through, a physical manifestation of a stable universe. But the celestial influence may have gone even deeper into the very tools of their trade. The Indus Valley civilization achieved something astonishing, a standardization of weights and measures that was consistent across a region larger than ancient Egypt or Mesopotamia. Their bricks, for example, were produced in a perfect ratio of 4:2:1, a standard used from one city to another hundreds of miles apart. How could such uniformity be maintained over such vast distances without a central, written command? The answer may lie in a shared concept of time and space derived from watching the same sky. A universal calendar, likely based on lunar or solar cycles, would have allowed for the coordination of harvests, festivals, and trade fairs. A merchant from Mohenjo-Daro could travel to a distant settlement and know that the standardized weight in his balance corresponded exactly to the one used there, because both cultures derived their systems from the same celestial mathematics. The heavens provided the invisible framework, the common language that made large-scale commerce and cooperation possible. This suggests their greatest astronomical achievement was not a structure, but a system. The orderly grid of their streets mirrored the orderly progression of the seasons. The uniformity of their bricks reflected the predictable cycles of the moon and sun. Their civilization was a machine of harmony, and the cosmos was the blueprint that kept every part in sync. They built a world that worked because it was, in essence, a reflection of a sky that worked with perfect regularity. This silent, celestial partnership allowed them to thrive for centuries, creating one of the most widespread and sophisticated cultures of the ancient world, all without leaving behind a single monument to the stars they so diligently followed. Their legacy is not written in aligned stones, but in the profound idea that a society's greatest strength can come from its invisible, shared connection to the rhythms of the universe. This celestial conversation needed a new language, one of lines, angles, and proofs. The ancient Greeks inherited a sky full of gods and omens from their neighbors, but they asked a different kind of question. They wondered not just what the heavens meant, but how they worked. Early Greek thinkers like Thales and Anaximander made a radical departure. Instead of seeing a solar eclipse as a divine omen, Thales is said to have predicted one by seeking a natural pattern. This was the first step in a profound shift, from interpreting the sky as a supernatural script to investigating it as a natural phenomenon. The pivotal leap came with geometry. A philosopher named Eudoxus took the chaotic dance of the planets, those wanderers that so troubled the Babylonians, and attempted to tame them with mathematics. He proposed a model of the cosmos built from 27 concentric, transparent spheres, each rotating at a different tilt and speed, all carrying the sun, moon, and planets in their complex path. While the model was cumbersome, its importance was monumental. For the first time, someone had tried to explain celestial motion, not with a story about capricious gods, but with the pure, predictable logic of geometry. The universe could be modeled, Then came an idea so ahead of its time it would be forgotten for nearly 2,000 years. Aristarchus of Samos looked at the cosmos and proposed a stunning rearrangement. He suggested that the sun, not the earth, was the fixed center around which everything else revolved. He even reasoned that the stars were immensely distant suns. This heliocentric model was a staggering conceptual leap, placing humanity's home not at the center of all things, but as a participant in a much larger dance. While his theory was ultimately rejected by most of his contemporaries, who favored the more intuitive Earth-centered models, it represents the explosive potential of this new way of thinking. The Greek synthesis was an intellectual revolution. It was the act of demystification, of carefully separating natural philosophy from pure myth. The sky was no longer just a divine message board or a clock for kings. It was a puzzle to be solved, a system whose principles might be uncovered through observation and reason. This shift from myth to geometry did more than advance astronomy. It created the very framework for science itself. It established the audacious idea that the universe operates by consistent, discoverable laws, and that the human mind, through logic and mathematics, could hope to understand them. This was the foundational leap that would later fuel the Renaissance and the scientific revolution, forever changing our place in the cosmos. But if the Greeks provided the intellectual tools to map the heavens, who would preserve this fragile light of reason when the world itself seemed to turn dark? The desert holds its secrets in stone and sand. Long before the pyramids rose from the Nile's banks, a different kind of monument was being assembled far to the west, in what is now the brutal expanse of the Egyptian Sahara. At a site called Nabta, a circle of stone stands as a silent, staggering puzzle. Created around 4,500 BC, this structure is not just old, it predates Stonehenge by over 1,000 years. It is one of humanity's earliest known attempts to build the cosmos on the ground. The people who built it were not settled farmers or city dwellers, they were nomadic cattle herders. In a landscape where survival was a daily negotiation with scarcity, these early people moved with the seasons, following the faint promise of water. And they looked up. Their stone circle is not random. Archaeoastronomers have found that key stones within the arrangement align with the rising point of the sun at the summer solstice, the longest day of the year. Other stones seem to point toward the positions of bright stars like Sirius and Orion's belt. This was a calendar carved into the earth, a way to mark the turning of the year with absolute precision. The implications of this are profound. For a long time, the dominant story was that complex astronomy was a product of settled, agricultural life. The idea was that only when people planted crops and built cities did they need and have the leisure to study the stars in detail. Nabta shatters that assumption entirely. Here were people living a mobile life, carrying their world with them, yet they felt the urgent need to create a permanent, fixed observatory in the desert. Why? Because their survival depended on it. Timing was everything. Knowing exactly when the summer rains would arrive, when the seasonal playa or lake bed would fill with water, dictated the entire rhythm of their existence. It told them when to gather their herds and begin the long trek to these life-giving pools. A mistake of a week could mean arriving at a dry basin. Their celestial knowledge was not abstract philosophy. It was a practical, vital technology for navigating an unforgiving world. The stone circle itself was more than a tool. It was likely a sacred gathering place, a site where clans would meet at appointed times, their reunions scheduled by the sun and stars. It represents a social contract written in the heavens. This discovery changes our understanding of civilization's dawn. It suggests that the deep human impulse to read the sky is universal and ancient, emerging not from luxury but from necessity. The sophisticated sky watchers of Nabta were not primitive precursors to the Egyptians. They were their intellectual ancestors. As the climate grew drier, these nomadic groups were likely pushed toward the reliable waters of the Nile River. They carried with them not just their herds, but a profound legacy of celestial observation. The practices honed in the desert to track water would, over centuries, be refined on the riverbanks to track floods, plan harvests, and eventually justify the divine rule of pharaohs. Nabta is a powerful reminder that the roots of empire are often found in the struggle for survival, and that the first great civilizations were built by people who had already learned to navigate by the light of the stars. The first written words were not about kings or love, but about stars. In the mud brick cities of Mesopotamia, astronomy did more than guide society. It demanded a whole new way of thinking, a technology of memory so powerful it would shape the human mind forever. The earliest forms of writing, wedge-shaped marks pressed into wet clay called cuneiform, began as simple accounting, tallies of grain and livestock. But the sky presented a problem that could not be solved with a simple list. How do you record the precise date of a lunar eclipse that might not repeat for years? How do you map the complex, 584-day cycle of Venus for the priest who will hold your office a century from now? The need to track these celestial patterns for both religious omen and state planning pushed cuneiform to evolve. Scribes began to develop specialized signs and complex grammatical structures to capture not just things, but relationships, sequences, and predictions. A tablet was no longer just an inventory. It could be a manual, a prediction, a permanent record of a conversation with the cosmos. This transformed writing from a tool of commerce into a vessel for abstract knowledge. The oldest known star catalogues in the world are cuneiform tablets, meticulous lists that named constellations and plotted the paths of planets against the fixed background of the night. These were the first databases, the original hard drives, storing celestial data across generations. This had a profound social effect. The scribe, the person who could read and write these celestial texts, became a figure of immense power. He was part accountant, part priest, part scientist. He held the keys to understanding the divine will and the practical calendar that ordered planting, taxation, and warfare. A new class was born, the literate administrator, whose authority came not from physical strength, but from mastery of this sacred, celestial code. Writing allowed knowledge to escape the fragile limits of human memory and the bias of oral tradition. An observation made in the reign of one king could be retrieved and verified 200 years later. This created an accumulating, self-correcting body of knowledge. Mistakes could be spotted, patterns could be compared across centuries, and the slow, steady work of turning celestial omens into celestial science could begin. The bureaucracy of the cosmos, in its demand for perfect, transmissible records, gave us one of humanity's most defining inventions. It cemented the idea that knowledge itself was a treasure to be preserved, and in doing so, it lit a flame of learning that would never fully go out. The power to read the sky was a form of sacred currency, and it was held by a new kind of elite. In the shadows of ziggurats and within temple courtyards, a specialized class emerged, the priest astronomer. These figures were far more than spiritual guides. They were the original data scientists, state planners, and royal advisors, all rolled into one. Their authority came from a single, indispensable skill: the ability to decode the language of the heavens. By carefully tracking the sun, moon, and planets, they could announce the precise moment for planting and harvest. They could, with growing accuracy, predict the terrifying spectacle of an eclipse. In a world where the divine and the natural were inseparable, this knowledge was the ultimate source of power. A king did not simply rule by birthright. He ruled with the endorsement of the cosmos, an endorsement only the priestly class could verify and interpret. When a ruler planned a military campaign, he consulted the stars through his priests. When he laid the foundation stone for a new temple, the alignment was calculated by these celestial architects. The priest astronomer became the essential link between the will of the gods and the law of the land. This specialization marks a fundamental shift in human organization. For the first time, a society could support individuals who did not farm, fight, or build with their hands. Their labor was intellectual. They spent years in training, memorizing star paths, perfecting mathematical tables, and maintaining meticulous records on clay tablets or papyrus scrolls. The temple itself often doubled as an observatory, its high platforms and aligned corridors serving as instruments for observation. These spaces became the first research institutions where knowledge was accumulated, tested, and passed down through generations. This created a self-perpetuating cycle. The more accurate their predictions, the greater their perceived connection to the divine, and the more indispensable they became to the stability of the state. Their monopoly on celestial timing allowed them to schedule everything from tax collection to public festivals, weaving the rhythm of the cosmos into the daily life of every citizen. This was not a conspiracy, but a natural evolution of complexity. Managing a large, agricultural society required a reliable calendar, and the sky provided the only clock accurate enough for the task. The individuals who mastered that clock inevitably rose to positions of immense influence. They were the first professional bureaucrats, using their esoteric knowledge to administer an empire, proving that the quest to understand the stars did not just reveal the universe, it invented the very idea of a governed society. But what happens when this carefully guarded celestial knowledge begins to escape the temple walls and filter into the broader culture? Light itself became the ultimate sacred ritual. Across continents and cultures, the greatest temples were engineered not just to house the divine, but to become vessels for celestial light. On one specific morning of the year, a beam of sunlight would pierce the inner darkness of a sanctuary, traveling down a long corridor to illuminate a statue of a god or a carved symbol on a far wall. This was solar geometry, a breathtaking fusion of architecture and astronomy where the building itself served as a giant stone calendar and a theater for the heavens. At the Temple of Karnak in Egypt, the axis of the entire complex is aligned so that on the winter solstice, the sunrise would shine directly down the main avenue of sphinxes and into the deepest, holiest chamber. For the priests and the pharaoh, this was not a pretty trick of light. It was the sun god Ra physically entering his house, renewing his covenant with the ruler and, by extension, with all of Egypt. The massive stone pillars, the towering pylons, the precise angles of every corridor, all of it was calculated to capture this single, transformative moment. The engineering challenge was staggering, requiring generations of precise planning and labor. This was architecture as a divine appointment, a date with the cosmos set in stone. The same principle guided builders on the other side of the world. At Karnak in India, the magnificent Sun Temple is designed as a colossal stone chariot for the solar deity Surya. Its entire structure is oriented with such precision that the first rays of the rising sun would strike the main entrance, and specific sculptures within the temple complex would be illuminated on the equinoxes. In Cambodia, the vast temple mountain of Angkor Wat is aligned to the west, a direction associated with the afterlife. Scholars have demonstrated that on the spring equinox, the sun rises directly over the central lotus tower when viewed from the main entrance, a perfect alignment that symbolically connects the king, who was seen as a god, with the cosmic order. These phenomena were far from accidental. They required an advanced, shared understanding of solar cycles, mathematics, and surveying that was passed down through priestly and artisan lineages. The purpose was profound. By orchestrating these celestial events, the temple became an active participant in the rhythm of the universe. It demonstrated, in the most visceral way possible, that the king and his priests held the knowledge to command the very light of heaven. For the common person witnessing the solstice illumination, it was a public miracle, a reaffirmation that their rulers were in harmony with the powers that sustained the world. This turned the temple into more than a place of worship, it became a permanent observatory and a powerful engine for social unity. The collective effort to build it and the shared awe experienced within it wove thousands of individuals into a single community bound by a celestial spectacle. The stones were silent, but once a year they spoke with the voice of the sun. One of the most sophisticated star charts ever created is written on tree bark. In the humid jungles of the Maya world, scribes produced beautiful, accordion-folded books made from the inner bark of the fig tree, coated with a fine lime plaster to create a smooth, white writing surface. These were the Maya codices, and they contained the accumulated celestial wisdom of generations. Of the thousands that once existed, only a handful survived the passage of time and the events of later centuries. The most famous of these survivors is the Dresden Codex, a 74-page masterpiece that is not a book of stories, but a precision manual for predicting the behavior of the planet Venus. It is, in essence, an astronomical almanac for a god. The codex contains complex tables that track the 584-day synodic cycle of Venus with breathtaking accuracy. It charts the planet's appearances as the morning star, its period of invisibility as it passes behind the sun, its reappearance as the evening star, and another disappearance. The Maya could predict these phases not just for the current year, but for cycles stretching far into the future. This was not abstract science for its own sake. In the Maya cosmos, Venus was a celestial actor of immense power, intimately linked to the feathered serpent god Kukulkan, known as Quetzalcoatl to the Aztecs. This deity was a bringer of both civilization and conflict, and the planet's first gleaming appearance in the dawn sky after a period of darkness was considered an especially potent and dangerous omen. The Dresden Codex provided the critical timetable for these moments of celestial influence. A Maya king planning a military campaign would consult these tables with his priests. Launching an attack under the auspices of Venus as the morning star was a strategic act of cosmic theater. It was believed that the war god's power was channeled through the planet, lending divine sanction to the battlefield. Victories were not just military achievements, they were validations of the king's ability to read and harness the celestial script. Defeat could be interpreted as a misreading of the omens or a failure to perform the correct accompanying rituals. This document crystallizes the ultimate integration of astronomy into the machinery of the state. The Dresden Codex is more than data, it is a tool of governance. It transformed the predictable rhythm of a planet into a schedule for warfare, diplomacy, and royal ceremony. It allowed a ruler to project power not just across the land, but through time itself, aligning his actions with the perceived will of the heavens. This represents a high point of pre-telescopic astronomy, where meticulous observation was directly wired into the levers of authority, guiding the political and military fate of entire city-states. The bark paper pages of the Codex are a tangible link to a world where the sky was not just watched, but obeyed, a world where the fate of kingdoms literally rose and set with a wandering star. The seafloor held a secret that would rewrite our understanding of ancient genius. In the year 1901, sponge divers off the coast of the Greek island of Antikythera stumbled upon a shipwreck, a Roman cargo vessel laden with statues and treasures. Among the corroded artifacts recovered was a lump of bronze about the size of a large book, encrusted with centuries of marine growth. It looked like a piece of junk, a corroded lump destined for a museum storage shelf. But decades later, when researchers finally peered inside using advanced imaging technology, they saw something that should not have existed: gears, dozens of precisely cut bronze gears arranged in a complex interlocking system. This was the Antikythera Mechanism, a device crafted in the 2nd century before the Common Era, and it is nothing less than the world's first known analog computer. Its purpose was to model the cosmos. By turning a hand crank on the side, an operator could advance a series of dials and pointers on the front and back faces. These moving hands would predict the positions of the sun and moon against the backdrop of the zodiac, forecast lunar and solar eclipses, and even track the cycles of the Panhellenic Games, including the Olympics. It was a portable planetarium, a mechanical almanac that brought the abstract geometrical theories of Greek astronomers like Hipparchus into a tangible, usable form. The engineering is staggering, involving differential gearing, a technique not thought to be invented until the 16th century. This single artifact proves that the Greek synthesis of geometry and observation had reached a level of practical application we never dreamed possible. But who was this device for? It was not a temple treasure locked away for priests. Its compact size and intricate, user-friendly design suggest it was a tool, perhaps for a wealthy merchant, a ship's captain, or a scholar. It had practical applications, calculating lunar phases for navigation at night, marking the dates of religious festivals and agricultural cycles, and possibly even providing data for the Hellenistic world's interest in celestial influences. Its very existence implies a workshop, a craftsman who understood both advanced astronomy and precision metalworking, and a clientele sophisticated enough to want and use such a device. This was not a one-off miracle. It is a surviving fragment of a technological tradition, a hint that the ancient world's mastery of the heavens had been mechanized. The Antikythera Mechanism stands as a silent witness to a lost path of scientific progress. It represents the pinnacle of a civilization that sought not just to understand the universe, but to build a working model of it. Here was the clockwork cosmos made real, a testament to the human desire to hold time and the stars in your hands. Its discovery forces a humbling question: how many other wonders of ancient technology lie buried, waiting to tell us that our ancestors were far closer to the stars than we ever knew? A single stone needle could slice the day into measured hours. The Egyptian obelisk, towering and slender, was far more than a monument to a pharaoh's ego. It was a colossal scientific instrument, a gnomon on a city scale. As the sun arced across the sky, the obelisk's shadow swept across the plaza at its base, a giant, slow-moving clock hand. Priests would mark the ground, observing the shadow's precise length and direction. At its shortest point, they found true noon. Over the course of a year, they tracked how the shadow's path lengthened and shortened, its reach growing in the winter and shrinking in the summer. The days when the shadow reached its absolute longest or shortest marked the solstices, the sun's turning points. The moments when day and night were of equal length, the equinoxes, could also be pinpointed with careful observation. This was astronomy made democratic, a public spectacle of time. Every citizen in the marketplace could see the evidence of cosmic order etched in shadow on the ground, an order maintained by the pharaoh's divine connection. The obelisk was a statement of control, proclaiming that the ruler not only understood the sun's journey, but could literally measure its passage for all to see. This concept of public celestial timekeeping traveled far. In the heart of a Roman forum, you would often find a large, horizontal sundial, its face engraved in marble on the pavement. These were not delicate garden ornaments but civic infrastructure. They regulated the rhythm of public life, signaling the opening of the courts, the start of market hours, and the time for political assemblies. The moving shadow synchronized a city of thousands, transforming the abstract, heavenly motion of a star into the practical, ticking minutes of commerce and law. These monuments did something profound. They embedded the astronomical rhythm directly into the urban landscape, into the very stones people walked upon. Time was no longer a vague sense of morning or afternoon. It was a visible, measurable fact authored by the sun and interpreted by the state. This shared temporal framework allowed for unprecedented coordination, turning a collection of individuals into a synchronized society. The shadow of an obelisk or a sundial was a silent, constant teacher, reminding everyone that their lives, from their work to their worship, moved to a celestial beat. The sky's secrets can be hidden in plain sight, whispered across generations in stories that seem like myth. In the Bandiagara escarpment of Mali, the Dogon people have preserved a celestial tradition that would later stun astronomers. Their oral histories and intricate rituals describe the star system of Sirius in astonishing detail. They speak of a tiny, incredibly dense companion star to the brilliant Sirius, which they call Potolo. This star, they say, is made of a metal heavier than iron and completes an elliptical orbit around Sirius every 50 years. For centuries, this was considered a beautiful cultural myth. Then, in the 19th century, Western astronomers with powerful telescopes confirmed the existence of Sirius B, a white dwarf star that is both incredibly dense and orbits Sirius in an elliptical path roughly every 50 years. The Dogon descriptions matched the scientific discovery with uncanny accuracy. This convergence sparked intense debate and wild speculation. How could a people without telescopes know about an invisible star? Some proposed dramatic theories of ancient alien contact or lost advanced civilizations. A more grounded, yet equally fascinating, explanation lies in the incredible endurance of cultural transmission. The knowledge could be profoundly ancient, a remnant of astronomical insight from a time when this information was more widespread, preserved through meticulous oral tradition and ritual. Alternatively, it might have been acquired through contact with other cultures. The Dogon region was historically connected to trans-Saharan trade routes and near the influential centers of ancient Egypt, where Sirius held paramount importance. An idea carried by travelers or scholars generations ago could have been adopted and woven deeply into Dogon cosmology, taking on a life of its own. The true answer may be a blend of both ancient observation and cultural exchange. What the Dogon mystery undeniably reveals is how astronomical knowledge can become fossilized within a culture's spiritual identity. Their knowledge of Sirius is not a detached scientific fact. It is embedded in their creation myths, their agricultural calendar, and their most sacred ceremonies, like the Sigwi festival held every 60 years, which mirrors the orbital cycle. This case powerfully corrects a modern bias. It reminds us that profound celestial understanding was never the exclusive property of so-called great civilizations with their pyramids and codices. It was and is a widespread human endeavor. Ideas about the stars flowed along invisible rivers of trade, migration, and storytelling, influencing and being influenced by diverse cultures in a slow, continental conversation. The Dogon are not an anomaly, they are a testament. They show us that the map of ancient astronomy is far more vast and interconnected than stone monuments alone can tell, with its routes written not in clay but in memory and myth. This realization opens a humbling door. How many other cultures hold pieces of a forgotten cosmic puzzle, waiting for us to listen to their stories? The gears of the Antikythera Mechanism turned on a hidden language. To speak with the cosmos, humanity had to invent a new vocabulary, one built not of words but of numbers and shapes. This was the birth of advanced mathematics, and its primary teacher was the restless night sky. Every time an astronomer tried to predict a planet's return or correct a drifting calendar, they hit a wall that only mathematics could break through. The great observatories of the ancient world were, in truth, the first advanced research institutes for numbers. Consider the Babylonian clay tablets. Their scribes, driven by the need to divine omens from planetary motions, became master calculators. They developed sophisticated arithmetic techniques and even tackled problems we would recognize as early algebra, all to solve for unknown quantities in their celestial predictions. They worked with a base 60 system, a legacy that still echoes in our 60-minute hours and 360-degree circle. a circle they likely chose because it closely matches the number of days in a year. Their math was not abstract philosophy, it was a practical tool for decoding divine messages. Across the world, the Maya faced a similar challenge with their intricate, interlocking calendars. To keep a 584-day Venus cycle in sync with a 365-day solar year and a 260-day sacred calendar required astonishing computational skill. In their Vajramal or Base 20 system, they performed complex calculations and, in a stroke of intellectual genius, independently developed the concept of zero as a placeholder. This was not just a mathematical convenience, it was a necessity born from their obsessive need to track time across vast cycles, to pinpoint a date thousands of years in the past or future for a royal ceremony. Their zero was a tool for cosmic bookkeeping. Then came the Greeks, who took a more geometric approach, trying to model the complex dance of the planets within Eudoxus's spheres, or later epicycles demanded a new kind of math. This need gave rise to trigonometry, the mathematics of triangles. Astronomers like Hipparchus compiled the first known chord tables, a precursor to sine tables, essentially creating a calculator for determining the positions of celestial bodies based on angles. They were mapping the sky with geometry. This symbiotic relationship reached another peak in ancient India. The brilliant mathematician and astronomer Aryabhatta, in the 5th century, explicitly used astronomical problems to propel his work. His text, the Aryabhatiya, contains revolutionary ideas for calculating planetary positions and the causes of eclipses. In doing so, he made pioneering advances in algebra, trigonometry, and even provided an astonishingly accurate approximation for pi. For him, the motions of the heavens were the ultimate word problem, and solving it required inventing new mathematical languages. This pattern is undeniable. The abstract beauty of mathematics did not emerge from pure thought alone. It was forged in the practical, urgent need to measure the immeasurable, to predict the unpredictable, and to impose human order on the celestial clockwork. The cosmos presented the ultimate puzzle, and mathematics was the key we crafted to solve it. Every equation, every geometric proof began as a stargazer's question. So, if the stars gave us the language of mathematics, what other fundamental pillars of our modern world were quietly laid by those ancient watchers of the sky? A spiral carved on a high desert cliff face became a calendar illuminated by the sun. Atop Fajada Butte in Choco Canyon, New Mexico, the ancestral Puebloan people, once called the Anasazi, engineered a breathtakingly simple yet precise solar marker. They carefully positioned 3 large stone slabs so that on the longest day of the year, the summer solstice, a single sharp dagger of sunlight would pierce the shadow and slice directly through the center of a carved spiral petroglyph. On the equinoxes, when day and night are equal, 2 daggers of light perfectly bracket the same spiral. This was no accidental play of light and shadow. It was a deliberate, calibrated instrument, a solar observatory built into the living rock of the canyon itself. The precision required to achieve this effect reveals a deep, generations-long study of the sun's shifting path across the sky. They understood the solar cycle with a clarity that allowed them to transform a cliff face into a giant, immovable sundial, marking the year's most critical turning points with a beam of light. This celestial knowledge was woven directly into the heart of their community. On the canyon floor below the butte stands Pueblo Bonito, the largest and most intricate of Choco's great houses. Its massive D-shaped structure is meticulously aligned to the cardinal directions, with its rear wall running perfectly east-west and its front wall facing south. This was not merely for architectural symmetry. The entire building was oriented to the cosmos, anchoring the community to the fundamental axes of the world. The combination of the sun dagger above and the aligned great house below creates a powerful picture. Their calendar was not kept on parchment or in a priest's memory alone. It was embedded in the very landscape they inhabited. In the high desert of the American Southwest, this knowledge was not philosophical. It was a matter of survival. The growing season was short and rainfall was unpredictable. Knowing the exact date of the summer solstice told them precisely when to plant their crops of maize, beans, and squash to maximize the use of summer rains. The equinoxes likely signaled times for major communal gatherings, for trade fairs, ceremonies, and the redistribution of resources across the vast Chaco network. Their solar calendar governed the rhythm of life, dictating when to sow, when to gather, and when the scattered clans should come together. This profound integration shows that the drive to read the heavens and build that understanding into stone was a universal human impulse. The ancestral Pueblones of Choco Canyon had no contact with the pyramid builders of Egypt or the astronomers of Babylon. They developed their sophisticated solar science entirely independently, responding to the same celestial cues but within the unique context of their desert world. The sun dagger is a powerful testament to a shared human genius. Across continents and cultures, when people looked up, they saw not just lights but a language. And from the sands of Egypt to the canyons of New Mexico, they found ways to write that language on the earth, creating a silent, enduring conversation between humanity and the cosmos. The great celestial clockwork can fall silent. Across the globe, the intricate systems of astronomy that had guided empires for centuries proved tragically fragile, tied not to the eternal stars themselves, but to the mortal societies that studied them. When those societies fractured, the knowledge often shattered with them. Consider the Maya world at the close of the Classic period. Their bustling city centers, once alive with the calculations of calendar priests, grew quiet. The construction of stelae carved with celestial dates ceased. The meticulous tracking recorded in bark paper codices slowed, then stopped. The very priestly class that maintained the cosmic schedule, the individuals who could predict the cycles of Venus and harmonize the sacred calendars, faded from history. Their sophisticated celestial science did not disappear in a single cataclysm, but rather dissolved as the social and political order that required it unraveled. The knowledge became a ghost, lingering in fragments and in the adapted practices of scattered communities. This pattern of loss echoed through time and across continents. The legendary Library of Alexandria, a repository for the combined astronomical wisdom of the Mediterranean world, suffered a fate emblematic of this fragility. Its gradual disappearance over centuries through a series of destructive events meant the loss of countless texts, including the works of Greek astronomers and the observational records of earlier cultures. A single fire could erase generations of accumulated insight. This demonstrates a profound truth. The preservation of complex knowledge depends entirely on stable, supportive institutions. When the ruling elite that funded the observatories and patronized the scholars falls, or when the temple schools that trained new generations close, the chain of transmission breaks. The so-called Dark Ages in Europe were, in part, characterized by this very recession. The sophisticated Greek geometry of the cosmos, the predictive models of planetary motion, became distant memories, preserved only in a few scattered manuscripts, often misunderstood. The shared public understanding of the sky as an orderly, mechanical system gave way in many places to a view of it as a realm of mystery and divine portent once more. This cyclical rhythm of discovery and loss reminds us that humanity's relationship with the cosmos is not a straight line of progress. It is a story of brilliant dawns and long twilights. Our connection to the stars has been broken and remade multiple times throughout history. Each renaissance, whether in Baghdad under the Abbasid caliphs or later in Europe, began by looking back, by rediscovering and translating those ancient texts that had survived by chance, by seeking to recover the lost language of the heavens. The fall of civilizations did not dim the stars, but it did extinguish the lamps in the observatories, leaving humanity to slowly relearn, once again, how to read the light. The long twilight of classical knowledge found a brilliant new dawn under a different sky. As Europe entered its early medieval period, a parallel intellectual revolution was unfolding across the Islamic world. From the 8th to the 14th centuries, scholars in cities like Baghdad, Cairo, and Cordoba became the custodians of the cosmos, actively preserving and dramatically advancing the astronomical wisdom of the past. They did not see the stars through a single cultural lens. Instead, they embarked on a monumental project of translation, gathering Greek, Persian, and Indian texts from the edges of their expanding empire and bringing them into a common language, Arabic. This was not mere copying. It was an act of synthesis, of comparing, correcting, and building upon centuries of thought. The Great House of Wisdom in Baghdad stood as the epicenter of this effort, a library and research institute where scholars of different faiths and backgrounds worked side by side to decipher the universe. Here, the geometrical models of Ptolemy met the precise numerical tables of Indian astronomers, creating a new, more robust foundation for celestial science. Figures like Al-Batani refined measurements of the solar year and the precession of the equinoxes with astonishing accuracy. Al-Sufi meticulously compared Greek constellation knowledge with his own observations, creating the Book of Fixed Stars, a work that named many stars we still use today, like Betelgeuse and Aldebaran. But this golden age was driven by more than pure curiosity. It was deeply practical, fueled by the needs of faith and state. Islam required its followers to pray 5 times a day at specific moments defined by the sun's position, and to face the sacred city of Mecca during those prayers. This created an urgent, widespread demand for precise timekeeping and directional finding. In response, scholars and artisans perfected an ancient tool into a masterpiece of mathematical engineering, the astrolabe. This handheld device, a complex web of brass plates and pointers, was a portable universe. It could tell the time day or night by measuring the altitude of the sun or a star. It could calculate prayer times for any location and date, and crucially, it could find the Qibla, the direction to Mecca, anywhere on Earth. The astrolabe became the smartphone of its age, an essential instrument for the traveler, the merchant, the farmer, and the devout. This fusion of religious observance, scholarly pursuit, and navigational necessity propelled astronomy forward. Observatories funded by caliphs and sultans rose in major cities, housing massive instruments for charting the heavens with ever greater precision. The work was not just about preserving a legacy, it was about making it live, breathe, and serve society. This era provided the crucial bridge, the unbroken chain of learning that carried the classical world's celestial insights through time. When Europe later reawakened to science during the Renaissance, it was often through Latin translations of these very Arabic texts. The Islamic Golden Age demonstrates a profound truth about human progress. Civilization is not a solitary sprint, but a perpetual relay. The torch of knowledge is passed, sometimes flickering, sometimes blazing, from one culture to the next, each adding its own light to the understanding of our shared sky. Nicolaus Copernicus quietly dismantled the universe. His masterwork on the revolutions of the heavenly spheres, published in the year 1543, was the spark for a revolution that had been smoldering for 2,000 years. He did not invent the idea of a sun-centered cosmos. Thinkers like Aristarchus had proposed it in antiquity. What Copernicus did was far more dangerous. He provided the detailed mathematical proof. By meticulously calculating the motions of the planets, he demonstrated that placing the sun at the center made the celestial dance far simpler and more elegant than the clunky, Earth-centered model inherited from Ptolemy and sanctioned by the Church. This was not just a new map of the heavens, it was a direct challenge to the entire philosophical and theological order that had structured Western thought since the time of the ancient kingdoms. For millennia, the cosmos had been constructed around humanity. The Earth sat motionless at the heart of creation, with the moon, sun, and planets revolving around it in divine concentric spheres, a physical manifestation of a great chain of being that stretched from the mud of the world up to the Empyrean heaven. This model perfectly reflected the social and spiritual hierarchy, with kings and popes at the center of their domains, mirroring the Earth's central, privileged place. Copernicus removed that anchor. In his system, Earth was demoted. It became just another planet, the third one out, spinning on its axis and hurtling around the sun. This was a profound demotion, a cosmic decentralization. If the Earth was not the center, then what was humanity's special role? Were we merely inhabitants of a rocky ball adrift in a vast, impersonal machine? The implications were terrifying, shaking the foundations of theology, philosophy, and human self-importance. The resistance was immediate and fierce. The Church condemned the work, placing it on its list of forbidden books. Many scholars rejected it as absurd, arguing that if the Earth spun, we would feel a constant wind or be thrown off into space. Yet, the mathematical elegance was undeniable. Copernicus had taken the long, winding thread of celestial inquiry, the observations of Babylonian priests, the geometry of Greek philosophers, and the precise tables of Islamic astronomers, and he had followed that thread to a conclusion that unraveled the very tapestry it was once used to weave. The ancient astronomy that had been harnessed to legitimize pharaohs and predict the will of kings had now produced a truth that threatened to dethrone humanity itself. This was the ultimate paradox of the quest to understand the stars. The knowledge we seek to affirm our place in the cosmos can sometimes reveal that our place is not what we believed it to be. The Copernican revolution was the moment the celestial guidance system, built over ages, finally pointed in a direction no ancient priest or emperor could have ever anticipated. The same stones that once channeled solstice light are now mapped with laser precision. Archaeoastronomy, the marriage of archaeology and astronomy, has moved far beyond simple speculation. Today, researchers employ tools like LiDAR, which uses laser pulses to see through dense jungle canopy, revealing the full scale of ancient cities and their hidden alignments. Three-dimensional modeling software allows them to simulate the sky as it appeared thousands of years ago, testing alignments with a click rather than waiting for a single dawn each year. This technological revival is proving that ancient astronomical intent was often more sophisticated and widespread than we ever guessed. But the legacy of those observations is not just historical, it is actively helping modern science. By analyzing precise records of ancient eclipses, particularly from Chinese and Babylonian sources, astronomers can detect tiny changes in Earth's rotation over millennia. A discrepancy of even a few hours between a recorded eclipse time and its calculated path provides critical data on the long-term slowing of our planet's spin, a subtle effect caused by tidal friction with the moon. Those priests watching for omens were, without knowing it, creating a data set for 21st century geophysics. The human impulse that built stone circles and solar temples has never faded. It has simply found new instruments. Our relentless drive to understand our place in the cosmos, first ignited by tracking Venus and plotting solstices, now fuels our most ambitious endeavors. We launch telescopes like the James Webb Space Telescope not merely to see farther, but to answer the oldest questions of origin, to witness the first light after the dawn of creation. We search for exoplanets in distant solar systems, scanning for the chemical signatures of life, continuing the ancient quest to see if we are alone in the vast, silent dark. This is the unbroken line, from an astronomer priest calculating the next appearance of Sirius to a team of scientists calibrating a space-based infrared sensor. Our modern technological civilization, for all its staggering power, is still engaged in the same fundamental conversation. We are still looking up and asking the sky who we are, where we came from, and what our destiny might be. The methods have changed from stone to silicon, but the longing remains written in our genes, a celestial curiosity first kindled beside a campfire under a canopy of endless guiding stars. The story of civilization is in its deepest layer a story of finding rhythm in the chaos. We have followed a single, luminous thread from the desert stones of Nabta to the bronze gears of the Antikythera Mechanism, and a profound pattern emerges. The leap from scattered tribes to interconnected empires was not merely a matter of agriculture or weaponry. It was first and foremost a cognitive leap, enabled by the silent, constant teachers in the night sky. Ancient astronomy provided the original toolkit for building a world. It gave us our first shared clock, turning the unpredictable flow of seasons into a calendar that could schedule planting, taxation, and ceremony for thousands. It gave us our first reliable compass, transforming trackless oceans into navigable highways that connected continents and ideas. But perhaps most powerfully, it gave us our first grand, unifying narrative. The movements of the sun, moon, and planets became a divine script, a story that explained why a king should rule, why a priest should mediate, and why a farmer should contribute to a temple. This celestial narrative offered something indispensable for social cohesion, a common purpose that was larger than any individual, rooted in the apparent eternity of the heavens. It justified hierarchy and centralized power by linking it to the cosmic order itself. The pharaoh ascended to the stars, the Maya king launched wars under Venus, and the Chinese emperor answered to the mandate of heaven. In every case, the sky provided the ultimate source of legitimacy, the original blueprint for the state. This was not a coincidence repeated across the globe. It was a logical response to a fundamental human need. Faced with a seemingly capricious natural world of floods, droughts, and disease, the predictable cycles of the cosmos offered a promise of stability. By observing and then mimicking that order on Earth through aligned temples, standardized calendars, and mythic rituals, early societies created pockets of predictability in a chaotic environment. They built not just with mud, brick, and stone, but with observed celestial law. The great rivers gave the soil, but the sky gave the schedule. Strong leaders gave the command, but the stars gave the timing. What we see in Egypt, Mesopotamia, China, Mesoamerica, and beyond is the emergence of a shared cosmic operating system. It was a system that managed time, space, belief, and power all at once. This deep, shared impulse to read the heavens and build society in their image speaks to something fundamental in us, a drive to find pattern, meaning, and our own place within a vast and ordered universe. That drive, first kindled by watching a star rise, is the same one that now propels our telescopes to the edge of the observable cosmos. That conversation with the cosmos never truly ended. From the first human who connected the rainy season with a star's return to the architects who built pyramids as celestial launch pads, our collective history is written in starlight. Ancient astronomy was the silent partner in civilization's birth, providing the original clock, the first reliable calendar, the most enduring compass, and a shared, sacred scripture that united thousands under a single sky. This journey through time reminds us that our ancestors were not primitive, but profound observers and brilliant engineers who constructed their entire world in a deliberate, ongoing conversation with the heavens. Their legacy challenges a narrow view of progress, showing that some of our greatest leaps forward began not with a tool of iron, but with an observation of light. Today, as we look up through light-polluted skies, we might feel a pang of disconnection from that ancient, visceral wonder. Yet the legacy of those star watchers is woven into the fabric of our modern world. It lives on in the 60 seconds of our minute and the 360 degrees of our circle, gifts from Babylonian calculators. It echoes in the precise orbits of our navigation satellites, the direct descendants of star paths tracked by Polynesian voyagers. It fuels our most ambitious telescopes, which continue the eternal human quest to understand our place in the grand scheme. A quest that began when someone first wondered why a particular cluster of lights returned with the spring rains. So let this exploration be a simple invitation. The next clear night, step outside, glance upward, and for just a moment consider the ancient, guiding light of the stars. That shared sky above you is the same canvas that inspired the builders of Stonehenge, the scribes of the Dresden Codex, and the astronomers of the House of Wisdom. Their story is ultimately our story, a testament to the timeless human drive to find meaning, order, and our own humble coordinates in the vast and beautiful unknown.